Alright, counting atoms. How do we tell how many protons, neutrons, electrons, all that kind of stuff are in an atom? Also coming up, we're going to talk about the average atomic mass and some different things that you find on the periodic table. It's going to kind of lead us into further chapters and eventually all the way to the mole and stoichiometry. So what we're going to talk about today, or in this lecture rather, is atomic number, mass number, and isotopes. I'm going to have a separate lecture for relative atomic mass and average atomic mass. That's kind of a difficult concept for some students because it deals with weighted average. Alright, atomic number. Atomic number is typically abbreviated with a capital Z, and the atomic number we find on our periodic table, and in our periodic table it's the large single-digit number at the top of our periodic table, tells us the number of protons. Now, the number of protons determines the kind of an atom. So if you look at the periodic table, you have hydrogen. You notice in the upper part of that box that hydrogen has the number 1. That 1 stands for 1 proton. If you look over at the next element on the periodic table, helium, the number that helium has, or helium's atomic number, is 2. That means that it has 2 protons. So, if we change the number of protons that an atom has, then we change the identity of that atom. Now, in this chapter, and as far as atoms go, the number of protons equals the number of electrons in neutral atoms. Now, in the next chapter, we're going to talk about ions, and that's going to be a little bit different, but for now, the number of protons equals the number of electrons in atoms, which all we're talking about right now are atoms. Alright, well, what about the mass number? The mass number is the number of protons plus the number of neutrons. Number of protons plus the number of neutrons. And in this example, it's carbon-12. This is what we know as hyphen notation. We'll talk about that in just a second. The 12 gives us the mass number. The mass number is number of protons plus the number of neutrons. Well, carbon, since it's carbon, we go to the periodic table, we know that carbon has to have 6 protons. Okay? Only carbon can have 6 protons. No other element on that periodic table can have exactly 6 protons. So, if we take that 6 away from the 12, we subtract those 2, which we can, then we get 6 neutrons. The mass number is always a whole number. Remember when we were talking about relative mass? Well, that's where we get this from, where we are dealing with the relative mass. Now, isotopes. What are isotopes? Isotopes are atoms of the same element, meaning they have the same number of protons with different numbers of neutrons. Now, if we change the different numbers of neutrons, then that's going to give us a different mass number. Alright, let's look at a couple of notations that we have for indicating the isotope or identity of an atom. These are known as nuclides. Alright, nuclear symbol. The nuclear symbol has 3, and we're going to add a 4th part later, but right now we have 3 parts. The chemical symbol, the mass number, and the atomic number. Okay? The chemical symbol is simply the abbreviation that we learned from chapter 1 for the atom. The mass number we should remember is protons plus neutrons, and the atomic number should be the number of protons. Now, carbon. Carbon is always going to have 6 protons because carbon is the only atom that can have 6 protons exactly. The mass number, however, can change. Say we have one or more, say we have additional neutrons. Well, that's going to create a heavier or lighter carbon. And hyphen notation is simply the element's name written out with a hyphen and the mass number. So why do we have different numbers of neutrons? Well, it all has to do with nuclear stability, which we will talk about a little bit later. But as for right now, we're just going to take it for granted that we have different numbers of neutrons. Now, we have 2 isotopes here. We have carbon-12, which we know carbon has 6 protons, and since 12 is going to have 6 neutrons, and we have carbon-14. Remember, 14 is our mass number. Our mass number is our protons plus neutrons. Since we have carbon we always know will have 6 protons, Okay, it's always going to have 6 protons. The element, or the atom, always has the same number of protons. Alright, the atomic number is the same. If you change the number of protons, then you change the identity of the element. But carbon-14 has 2 extra neutrons, which which makes it nuclear unstable. Makes the nucleus unstable, which makes it radioactive. And we oftentimes see carbon-14 used in radioactive dating, which we're going to talk about a little bit later in chapter 21 as well. Now, one thing you need to note here. The number of protons equals the number of electrons in neutral atoms, because you have to have just as many positives as you do negatives, or you have to have just as many negatives as you do positives, so that those charges will cancel because we are dealing with neutral atoms here. Now, we can determine several things from either hyphen notation or the nuclear symbol from these nuclides. For example, chlorine 37. Well, we can determine the atomic number, the mass number, the number of protons, and the number of neutrons and electrons from this hyphen notation. Chlorine, if we go to our periodic table, chlorine has an atomic number of 17. That means there are 17 protons located in the nucleus. The mass number, which we get from our notation, is 37. The number of protons that we have, we know, equals the atomic number, which is 17. And since this is a neutral atom, the number of protons equal the number of electrons, so 17. Now we have to do a little bit of math to figure out the number of neutrons. Now, you should remember that the mass number is equal to the protons plus the neutrons. So what we can do is we can solve for neutrons by simply subtracting 17, or the number of protons, from our mass number, and we get 20. Now, what is our nuclear symbol going to look like? Well, we're obviously going to have chlorine symbol, which is Cl, and the mass number at the upper left-hand corner, and the atomic number at the lower left-hand corner. Mass number, atomic number, element symbol. Alright, now we can go back the opposite direction from a nuclide, or from a nuclear symbol. So let's find the number of protons, neutrons, electrons, the atomic number, and the mass number. Well, fluorine, we can go to the periodic table and look for fluorine's atomic number, which is going to be 9, or we can get that from our symbol, which should be 9. Oops, I forgot this slide doesn't have it on it. Now, the number of neutrons we know is equal to the number of protons plus the mass number. The mass number of fluorine is 19. So we can subtract 9 from 19 and get 10 neutrons. The number of electrons equals the number of protons, which is 9. The atomic number equals the number of protons, which is 9. And the mass number is displayed for us in the upper left-hand corner, which is 19. Okay, we can do it again on this one. We can find the protons, neutrons, electrons, the atomic number, and the mass number. I'll give you a second just to look at that if you want to pause the video and work it yourself. Alright, bromine, we can go to the periodic table where we can simply look at the symbol and say bromine has 35 protons. 35 minus 80 is going to give us what? (45) neutrons. The number of electrons equals the number of protons. So we end up with 35 electrons. The atomic number is 35 because that equals the number of protons, and the mass number is 80. Now, now we can start to determine things from this note, from a problem given here, like you might see on an exam. It says if an element has an atomic number of 34 and a mass number of 78, what is the number of protons, number of neutrons, number of electrons, and the complete symbol? Right. I'll let you do this on your own, but atomic number equals the number of protons, which is 34. Number of neutrons equals the mass number minus 34, which is going to be 78 minus 34, which will be 44. The number of electrons equals the number of protons, which is 34, and the complete symbol is either going to be selenium-78, or if you do a full nuclear symbol, it's going to be Se with 78 in the upper left-hand corner, 34 in the lower right-hand corner. This is another example. If an element has 91 protons and 140 neutrons, what is the, and it gives you the things to work. Typically we go over these in class. Hopefully I don't have to go over these. And if you're using hyphen notation, it's very simple to go back from. I have two isotopes of uranium. Remember, isotopes have the same number of protons but different numbers of neutrons. Uranium-235 and uranium-238, which you may have heard of as being kind of what everybody wants in terms of a nuclear nation. These are the energy producers, and the nuclear weapon producers, weapons of mass destruction producers. But those are the mass numbers. We can look up uranium. We know that uranium has an atomic number of 92. So we can subtract 92 from each of these and determine the number of protons, neutrons, and electrons in each.